In the last video, we had just gone through the process of finding that the tension through the wire supporting the bar is 383 newtons, but we still have to determine the strength of the force exerted on the bar by the wall. And this is where our earlier equations using Newton's second law in linear form will come into play. We had earlier concluded that the force in the x direction from the wall on the bar is going to equal the tension in the rope in the x direction. And we had seen in the y direction the force from the wall in the y direction plus the tension in the y direction minus the two weights of the bar and the sign have to cancel each other out. And so that would be an easy way just to go through now that we have t and we have ty. We found that as an earlier step. We could use some trig and get tx and then just immediately know our two components for that force. So let's start with the y direction. So the force in the y direction plus the tension in the y direction, 314, minus the bar's mass, 8 kilograms times 9.8, minus the sign's mass, 12 times 9.8, all has to equal 0. And so just combining our constant values here, we get that the force in the y direction is negative 118 newtons. And all that negative tells us is that the direction that the force is actually pointing in is opposite of our predicted value. We had said, oh, let's say Fy is pointing up, and by recovering that negative, we know in fact the force in the y direction from the wall will be pointing down. So that's part of our force from the wall. The second part here is using this earlier relationship, Fx equals Tx. Well, the tension in the x direction will be T cosine theta from our trig we had set up earlier. And so the tension was 383 cosine 55 degrees. And so the force in the x direction looks like it's 220 newtons. And so we got a positive sign saying, yeah, we did predict it is going to point to the right here. All right, last bit. It doesn't want the components. It wants the actual force itself. So we have one last bit of trig to do, our Pythagorean theorem. So we have Fx, Fy, but we are looking for the magnitude F, which is our hypotenuse of this right triangle, if that line will work at all for me. And so we can use, like I said, Pythagorean theorem. So F is going to be the square root of Fx squared plus Fy squared. And so putting in those values, 220 squared plus 118 squared. We can just drop the negative since a negative times a negative is going to be positive anyway. And we get, let's see, square root 220. Looks like the magnitude of the force from the wall on the bar is about 250 newtons. And it didn't ask for what angle that's at, just wanted the magnitude, so that works as our full solution.